Welcome everyone. Today let us solve the lead codes daily challenge. The problem is rectangle area. Given the coordinates of two rectilinear rectangles in a 2D plane, return the total area covered by the two rectangles. The first rectangle is defined by its bottom left corner ax1 and ay1 and its top right corner ax2 and ay2, and the second rectangle is defined by its bottom left corner byx1 by1 and its top right corner bx2 and by2. So these are the inputs that are input values that are given, and we have to find the area, total area covered by this two rectangles. How we can find the total area of the rectangle? We can say area of rectangle is nothing but length into breadth L into B. So, so to calculate the area of this rectangle, around the points that are given are minus 3 comma 0. This is ax1 ay1 and ay1 and ax2 ay2 are 3 comma 4. So to calculate the length, we can just say 3 minus of minus 3, which is 6. And to calculate the breadth, this is length, and to calculate the breadth, it is nothing but 4 minus 0. This is as simple as that. So we will get the length and breadth, and we can just multiply 6 into 4, which is 6 4 24. So this is the area of the first rectangle, and the area of second rectangle is nothing but, first we can take the points 0 comma minus 1, and the other point is 9 comma 2. To get the length, we can say, to get the length, it is nothing but 9 minus 0, which is 9, and to get the breadth, it is 2 minus of minus 1, 2 minus of minus 1, which is 3. So the total length into breadth area, total area of the second rectangle is nothing but 9 threes are 27, 9 threes are 27. And we know the total area of the rectangle that are covered by the, if it is not overlapping, then the total area of the rectangle is nothing but 51. 27 plus 24, which is 51. But you can see that these rectangles are overlapping in some places. The area of the overlap is nothing but the breadth is 2 and the height is 3, so 3 2s are 6. So the total area that are overlapped by the two rectangles are 6. So we just subtract 6 from the total area that we got, which is nothing but 45, and that is our required answer. So they are given the 45. So consider we are having this rectangle. So how the key part for this problem is to find the overlap region. How we are going to find the overlap region? Let us try to take some examples. If we are having like this, if we are having a coordinate, if there is a rectangle which is starting from the point x1, this is consider it as ax1, and consider this point as bx1, sorry, consider this point as ax2, sorry, this is ax2, and if there is some other point, the rectangle starts from bx1, and this is bx1, and let's say the rectangle's x direction is in somewhere here bx2. If this is the case, then there is no overlap between them. You can see this ax2 is lesser than bx1, so always this is going to be lesser, so this is not an overlap. So you can consider this as a merge interval. So how we can find there is a overlap? So if there is some coordinate, if there is a line like this, and we have ax1 here, we have ax1 here, and we have all the possible variations, like we can have some bx1 here, bx1, here, and we can, let's say, ax2 ends here, ax2 ends here, and bx2 ends here. As you can see, there is an overlap here. So if there is an overlap in this case, how can we find this overlap? The overlap is nothing but this distance. If we are able to find this distance, this is the x overlap, and for the similar way we can find for the y direction as well, y axis line, and we can find the y overlap. So how we can find this is, we can do by calculating the overlap by min of, I will write the formula here. We can calculate the overlap by min of ax2 comma bx2 minus the max of ax1 comma by1, sorry, bx1. So by this way we can just calculate the overlap region by ax, taking the min of ax2 and bx2, taking the min of the x2 direction, min of this, by taking the minimum of this ax2 and bx2, and the maximum of this ax1 and bx1. If we are able to take that region, and we can just subtract them, if the subtracted region is greater than 0, then we will say there is an overlap. If we will say there is an overlap, this is nothing but the x overlap. And similarly, we can also calculate the y overlap by taking a y2 minus a, the minimum of a y2 and b y2, and the maximum of a y1 and b y1. So let us trace this overlap region by using this. So what is the minimum of ax2 is nothing but 3, and bx2 is nothing but 9, and the maximum of ax1 is minus 3, and the maximum of and the bx1 is 0. So you can see the minimum is nothing but 3 and the maximum is 0, and 3 minus 0 we get some positive integer that is greater than 0, so we get some overlap region as 3. And similarly we can find the, for the y direction, the ay2 is 4 and by2 is 2, and the maximum of so by taking the minimum of the x2 y2 direction, ay2 and by2 is 4 comma 2, and the maximum of ay1 is 0 and by1 is minus 1. And we can if we reduce this, minimum of 4 comma 2 is 2, and the maximum of 0 comma minus 1 is 0, so the total distance we get is 2, and the overlap region is nothing but 3 cross 2, which is 6. So we can get the overlap region by this way. So by this, using this formula, we can just solve this problem in the time complexity order of 1. Let us try to do that soon. So we want area of rectangle 1, and which is nothing but we can use the formula easily, which is nothing but how we are calculating the area of the rectangle, dx1 minus ax1 multiplied with dx2 minus ax2. So 3 minus of minus 3, this is sorry, we are later, this is nothing but ax2. ax2 3 minus of minus 3, which is ax2 minus ax1, and bx2 is 9 and bx1. By this way we can get the area of the rectangle. Sorry, ay2 minus ay1. So this is the area of the rectangle for first rectangle, and the second rectangle is nothing but the bx2 minus bx1 multiplied with by2 minus by1. This is the two area of the rectangles. Now our final answer is nothing but, we can say it as total area. The total area is nothing but area 1 plus area 2 minus the overlap region, and we can return the total area at the end of the day. So before calculating this, we want to calculate the overlap region. So we can have something like int x overlap which is initially 0, and y overlap which is also initially 0, and we can also declare some overlap to be 0. Now how we can calculate the x overlap? By the formula, by this formula we can just take this out. So we can just calculate like this, and this is the x overlap and this is the y overlap. So minimum of y2, minimum of ay2 minus by2, and the maximum of ay1 and by1. And now we have to see whether this is giving a positive overlap. If x overlap, if our x overlap I is greater than 0, and y overlap, if x overlap is greater than 0 and my y overlap is greater than 0, then my overlap part is nothing but the x overlap multiplied with y overlap. So we have got the overlap area, and finally we can just return like this: area 1 plus area 2 minus the overlap. Let us try to run our code. Okay, we get our correct answer. So the time complexity for this solution will be in order of 1. Now let us submit, and the space complexity is also order of 1. So hope you like the solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.